So here we are. This is Gordon from gCreate, and we're doing the next part in our video series on how to design, slice, and 3D print the gCreate rocket. In this next couple videos, we're going to use Simplify3D to slice it, and we'll show you all the settings, and then we're going to go ahead and print it. So hopefully you saw the other videos, and enjoy the next one. So if you've downloaded our configuration files from the website and loaded Simplify, this is what you see. This is an empty space ready to have a model dropped in. One thing you'll notice is that we can actually make this space look even better by importing our 3D model for our printer in the background. If you've seen our config files, there should be a link to how we're basically describing how to do this, but I want to show you real quick right now. If you've already seen it, this will be fast. Don't worry. So what you're going to do is go to Tools, and then go to Options. Under the Machine tab, there's a spot that says Printer Models. So we've actually made an STL file of our own printer, and you can go ahead and import that as a background model. So go to Add, and then you're going to go ahead and select your model. Once you have your model selected, which you can download from our website, you just hit OK. You can change the color of the model. This gray happens to come out more like a black, but that's why we left it gray. But here you go. And there we go. There's the background of our printer. It's very useful to see what the front of your printer is, what the back is, and just kind of give you a general scale for real life, because once you have the printer in real life, you can actually see the size of the model on the printer bed. Okay, so now that we've imported our background, we can go ahead and import our model. The great thing about Simplify3D is you can just take your 3D model and drop it right in the program. And we're just going to go ahead and drag the file straight into the program, and there it is. This is what the model looks like at full scale. You can scale it down slightly. We recommend not going too small, but I think we printed this at 50% scale, and it had no problems. So it's made to be printed at full scale, because obviously if you want to put coins in the top, a quarter, this just barely fits a quarter widthwise. So you can't go too much smaller than that. But it depends on the size of your printer. So, okay, now we pulled the model in. What you want to do, when you first pull the model into Simplify3D, it'll actually make an automatic process for you. So this process will be based upon the last settings you used for the program, which is nice, but also sometimes kind of cumbersome because you may have changed things that you don't remember. I'll show you how to kind of take care of that in the future, but for now, whatever settings we used last time should be saved in here. So we'll see what that looks like. Go ahead and click Edit Process Settings now. And apparently I used the 1.2 millimeter E3D nozzle last time, so I must have been testing with that. What we want to do for this particular model is we're going to go ahead and print it in the 0.4 E3D all metal hot end, because we wanted to test that as well. So we already have a series, the left and right extruders, that's the 0.5 millimeter J head hot ends, which comes standard and equipped with every gMax. And then we've been testing with the E3D nozzles from various different sizes. So we're going to go ahead, instead of trying the 0.5 millimeter, which is standard for ours, we're going to try the 0.4 millimeter E3D all metal hot end. So to add a hot end, you just go to Add Extruder, and what it'll do is just basically you type in the name of your extruder, and it'll give you all the same settings you see right here. Now, a very important thing with Simplify3D is after you've added your extruder and tweaked your settings and your retraction and everything else, you have to kind of turn that extruder on, if you can call it that. So now that we've added it, what we would like to do is go ahead and go to your layer, and you'll see primary extruder. These are all the extruders you have available in your printer. So if you've added a new extruder, you should see it in this list. If you don't select your extruder from this list, it will not use that extruder. So whatever one you do select, you have to kind of pick here. So if you want the 0.4, now for all the layer settings, it'll use the 0.4. If you go to your other settings, you still have to also select them. So you'll see them in a minute. But let's go ahead and go through these changes first. So for this particular model, you really 2.2 millimeter layer heights is really fine, and it's a great layer height. It'll be a nice balance between speed and high quality printing. You can go higher. You can go to 2.4 or 0.24 or 0.28, 0.32, anything. We recommend for our printer going in 40 micron increments, hence the 0.24, 0.28 jump. But this should be fine. What I recommend for everybody the lower you go for your layer height, the more you have to increase your top solid layers and your bottom solid layers. So this right here is the absolute minimum you should do if you have a 0.2 or 200 micron layer height. In some cases, you want to go to 3 or 4 and then 3 because this is the number of layers you have at that thickness. So if you have a 400 micron layer thickness, well, you really only need 2 solid layers because that's 0.8 millimeters. If you have a 200 micron layer thickness, you need 4 solid layers because that's, again, 0.8 millimeters. So the lower you make this and the finer you make your layer height, just keep increasing your top solid layers and your bottom solid layers. That's the number of actual solid infill layers it'll do for the top portions of your model and the bottom portions of your model. If you don't increase this, you will see gaps. You might see a very thin top or bottom layer. If you're finishing the model, it might not matter, but if you're not finishing it, you'll see through inside your model sometimes, and you will see gaps. So, okay, the next are perimeters and shells. How many perimeters and shells, basically outside walls, do you want in your model? 2 or 3 is typically fine. I usually don't do more than 3 unless we're doing a very solid part. Let's say for the 3D printed parts in our printers, we might do 4 or 5. But for the most part, 3 or 2 is fine. This is probably the most important setting in the printer. Your first layer height is very important. When you're printing on such a large printer bed, such as ours, you really want to have a very thick first layer height. So in some cases, 200% of 0.2, which is 0.4 millimeters, is not enough. Sometimes you want to go as high as 400%. That'd be 0.8 millimeters. So if you have high or low spots in your bed, increasing this number here will really fix that problem, because if you have a low spot, it'll just spit out a lot of plastic and kind of make up that difference. So, a lot of times your first layer is the chance for you to kind of flatten out the bed, especially if you're doing a very large print. Now, the next thing, aside from the layer height, is the width of the first layer. If I saw somewhere on one of our forum posts that somebody was printing a bunch of squares, and they had these really squiggly kind of like ripply lines for the first layer. And what was happening was that the first layer was not, it was printing a little bit fast for a very large open flat area, and the plastic, as it's trying to lay down, is actually kind of peeling up and creating these ripple patterns. So it actually looks terrible, and it's not really like a flat solid first layer. So to solve that, you can increase the first layer height, but also decrease the width sometimes. So this will do 55% of the width of a normal layer. So if your normal layer is a 0.4 millimeter nozzle, 55% of that means you're going down somewhere near 0.21 millimeters width. So it's a pretty thin layer. And that sometimes has caused the first layer to stick a little bit better, and the bottom of the first layer to look perfect. So tweak these two settings, the height and the width, and sometimes that'll fix it. And also, I guess the third thing you say is the speed sometimes helps. If you print the first layer a little bit slower, sometimes that'll kind of fix that problem as well. So the settings we're going to use for this particular rocket, I think we did 250, I did 65, and I'd like to do a slower first layer speed. Now, let me just go ahead and stop here first, and I'm going to go ahead and show you. This is a very interesting model because it's kind of like our torture test. It has extreme overhangs in some cases. It's a big print. It has a very small surface area. So the bottom of the print has just this little pad here, here, and here, as well as these tiny little rings here. So it's a kind of a tricky model, and it's a great model to test your printer on because it has bumps out that might create problems, and I mean, it just has a series of great little issues, which is also the other reason we designed it the way we did. In this particular example, because the first layer has such small pads to adhere to the print area, what you want to do is, initially we created these kind of triangular connecting points that would connect to 3 nozzles, and then you would cut them away later. But if you don't have that, what you can do in the slicing software is go to the next tab, which is called Additions. Here you'll see skirt/brim. Now this is basically used, typically you'll see something like 4 here, and this will be 1. What this will do is just basically start your print up, what I should also mention is constantly, especially if you have a good computer, tweak these settings and then go ahead and slice it and see what it looks like. Because then you can really test before you print what you're doing. So right now I went ahead and just hit the what was it called? Prepare to print button, and then you can actually see the G code output of all the layers with all the settings you just set up. So now you can see like, well, if I tweak this, what's it actually going to do? So you should tweak and hit that button all the time to see what you're doing. So okay, jumping back to what we were talking about a second ago, this here now, this is the skirt. What it's doing is just starting the plastic to flow so that when you actually start the actual print, it's already been flowing for a second as opposed to just starting with kind of an empty nozzle. Now you can kind of trick your model and use this as a tool because we have such small areas to print on. So again, in this example, you'll see that I turned on the skirt. Now what I want to do is go back to Edit Process Settings, go back to Additions, and I want to have skirt layers. One is fine. You just want one layer. Now the offset from the part you want to be 0. So you want to have it stuck to the edge of the part. Now the outlines number, you want to put something like 8 or 10. Let's try 8. Hit OK, and prepare to print. Now what this should do is create a series of skirts that are stuck to the outside of each one of these sections, so that when we print, it'll have a much larger surface area that's actually stuck to the actual bed. And this is very useful. You don't have to use a raft. You can cut this away later very easily with like an X-Acto. But here you see there's a series of skirts that are going to print around the first layer, all these spots. And then cutting them away is very simple. There's no crazy raft you have to deal with. Like you literally just increase the surface area of your first layer by, in some cases, 3 or 4-fold by simply just clicking one button. So now that we've kind of previewed that first layer, we can go ahead and get back out of exit preview mode. Now we can go ahead and tweak the rest of the layers we want. So we know that we have a good surface area. We know that the first layer should hopefully stick pretty well. We typically print on acrylic because out of all the materials we've ever tried, it is still by far the best. It sticks so well with PLA, and it's not too much, it's not too little. We don't heat it. You literally just print straight on acrylic, and it just sticks amazingly well. Even if you use a very high first layer height, sometimes it's perfect. So let's go ahead and go back to Edit Process Settings and keep tweaking the rest of the settings. So as we mentioned, all this is set. The additions now, if you want to increase the outlines, you can. It really costs very little material. You're talking an extra penny or two in material, and it really will make sure that your first layer or your print doesn't pop off the bed during the print. But 8 should be fine. Next, you go to Infill. Actually, sorry, what I forgot to say was, if you go to Layer, here we have the 0.4mm E3D nozzle. When you go to Additions, you have to select the same thing. If I didn't check this, this would try and print it with an extruder that's the wrong size. So go ahead and click that. Go to 0.4. Same with Infill. You want to go to 0.4. The one bad thing is when you first pick your nozzle, you can't really just pick a nozzle here and have it change everywhere. You have to just make sure that when you make a new nozzle or that's the one you want to use, you just pick the first 4 tabs, and then you have to make sure you change it in all of them. So now we changed it here. Now what I like to use is the triangular infill pattern. Every different pattern has its own kind of benefits and minuses, pluses and minuses, but the triangular seems to work quite well. What I like to do is go from 0, 60, -60, and then I add 90 because that doesn't exist. So to add it, it looks like this normally, and then you just go to 90, say add angle. Now you have all 4. And then by default, when you pick triangular, you'll see this here comes on. I don't like that. It just slows the print down immensely. So I'm going to turn that off. And that means that the first layer, it'll print 0 degrees. The second layer, it'll print 60. The third layer, it'll print -60. And the fourth layer, as we just added a second ago, it'll print 90 degrees. So that's a nice way to kind of set up a good infill pattern. Now, percentage for this particular rocket, 18 or 20% is really fine. You don't really need it that dense, and really the only reason you're possibly using infill almost at all is because there's certain portions of the model kind of in here that need to have a base in order to start printing from. So that's the only reason you want to add it. Outline overlap, this is very important. Lately I've been playing with a few models where we're doing hollow models. So the top and bottom layers are solid, but everything inside of it is hollow. And increasing this number to something like 40 or 50% has been has made a dramatic difference. How about that? It has made it so that we can actually, you know, bridge 2, 3, 4, 5 inches with absolutely no sag and no problems, and the model doesn't have any holes when you're done. Like it literally, this is just how much the infill is going to overlap the outside perimeters. So if you set this to 10%, then your infill will hit 10% of the outside outline perimeter and then go back. Well, if you hit 40 or 50%, it'll pretty much overlap 50% of your outline and then your perimeter and then come back, which is very nice, especially if you're doing a lot of bridging or whatever. The problem is if you do this too high, you might even see the outside of your model, basically the outermost perimeter of your model might be affected by this overlap. You might see some bubbling or some whatever. It might not look as clean as it should be. So 40% is about as high as we've gone, but it's been a great setting to play with, especially if you're doing bridging. Extrusion width, all these settings, again, you can play with. You should try small models, test them out, see what happens. But this is what we use for this model. The infill extrusion width, 100% is fine. Minimum infill length, that's just something that, the lower number you put here, that's where it actually will include infill. If the number's if you put it to, let's say, 200 millimeters, then anything that's 200 millimeters or less will not be included in the infill calculations. So you have a lot of empty spaces in your model. Doesn't really help us in this case. And then the last thing we did was print sparse infill every 2 layers, which this means basically that it'll skip every other layer for infill. So it'll infill one layer, and then the next layer there'll be no infill. And the layer after that, there will be infill. And also the infill will be double the thickness, so it'll be really thick. This will speed up print time, but in some cases it'll really hurt your model. So in this case, we turned it on just to kind of try it out and play with it again. But it's not meant for everything. Typically, you want this to be 1, but in this case, we'll try it as 2. That's pretty much it for infill. So next is support. What we want to do is turn on support material. Now, I'll show you in a second why we did that, but basically, we don't want support everywhere. We want support in literally one spot in the model. This is one big change for this new model versus the old models we did for the old rocket. But let's turn it on here and then make sure that the extruder we're using is the 0.4 or whatever one you want to use. But if you're using the normal 0.5, keep it at left extruder. But in this case, because of all the other ones are 0.4, and then here is 0.4, we need to make sure we select it here. So for the support infill percentage, 30% is fine. It's kind of up to you how thick you want it to be. The thicker you go, it doesn't necessarily help you, but in some cases, if you're doing a lot of support or you want to make sure your first layer is thick, you might need it thicker than that. But 30% is fine. Now, again, you should always, as soon as we're done with this, we're going to go back to prepare to print because it's really important to check your model all the time. But for now, we're going to go ahead and just tweak these settings. Now, dense support layers. What happens is it'll do 30% support for kind of the scaffolding as far as it needs to go. And then as soon as your support material gets to the point where it's just below a spot where it's actually supporting something, where it's actually doing the work, then it'll create these really dense layers. And that's what your actual model will then go ahead and build upon. So setting this number to 2 is usually pretty good. You can go as high as 3, 4, or 5 or whatever, but it doesn't, in my opinion, it doesn't seem to help much. So 2 is a good number. And then how thick do you want the dense support layers, the layers right below your actual model? And then 75% seems to be good for that, because if it's a little gappy, it doesn't matter because you're going to rip it apart and throw it away anyway. But in this case, if you go too thick, it's a problem. Then you could also do print support every X layers. You can do it to 2, 3, 4, whatever you want. That'll do the same thing as the infill. It'll skip every other layer for support or every third layer for support or whatever. Now, going in hand in hand with the dense support layers kind of is the offset of the support from the part. So wherever these dense support layers are kind of building up, This number is how far away from the actual 3D print are those layers. So in this case, 0.4 millimeters is just fine. That's kind of your standard, and just go with it. Okay, now everything else you can kind of leave where it's at. Now I want to show you something really, really cool with Simplify3D and support. So if we were to go ahead and generate support right now, let me go back to support. Let's say our max overhang angle, if you do, you can kind of leave your mouse over. If you do 90 degrees, that's considered your vertical, and 0 degrees is considered horizontal. So if we do 20 degrees, which is closer to a horizontal, and then prepare to print, and you'll see we have support material everywhere. That's not really what we want. This model was designed to be able to print without a lot of support, and this is a ton of support. I mean, literally, look at it. You can't even see the model. If you look at the weight, it's 307 grams of plastic, and what is it, 102,000 millimeters of filament. And this number here, build time, 14 hours and 34 minutes. For whatever reason, seems to be always about 10% off. So it's actually more like 15 and a half hours or 16 and a half hours, or let's say 16 hours of print time. So this is not what we want. This is way too much support. We're going to rip it all apart anyway, and it doesn't help us. So as I mentioned a second ago, a really cool thing about Simplify is you can define where you want support. So let's get out of this, and then let's go to, there's a button here. This button is called Customize Support Structures. So click that. And, oh, sorry, it came on the other screen. You'll notice if I, just like kind of the same numbers as before, if I click Generate Automatic Supports, it'll be the same thing you just saw, support everywhere. Now, we don't want that. What we want is to add new support structures, and we're going to do it ourselves. But before that, we want to make them a little bit thicker. So let's go to 7 millimeters. And then let's go to the bottom of the model. Now, one thing you'll see that's different in this model is this nose cone here. We used to have a built-in support system in the old model just below here, and it caused a lot of problems. So we went ahead and just took it out, and we just allowed people to go ahead and make their own support material, because you really only need it here. So especially in Simplify3D, it's very easy to add support. So let's go ahead and actually, I should make a quick note. In the future video you're going to see, I didn't do this step. I forgot to add support here. So during the print in the time lapse, this area got all gobbledygooky and just printed in midair. The print actually turned out fine. I just lost this nose cone on the bottom, but so it doesn't really matter if you're not. I mean, it does matter, but it wasn't the worst thing in the world for me to forget support here. But if you want to save this cone, you need to add support. So this is very important if you want to actually use this rocket with, especially with the smoke stand. So back to where we were, we have generate support. We set it to 7 millimeters, and we're gonna go ahead and do add new support structures. Now you'll see we have these kind of columns of whatever. This is going to define, every one of these we click will define where the support goes, and it'll go down to the build plate, which is why you see it at a certain height. So what we want to do is click them all around this particular cone here. It doesn't matter if they overlap, because it'll just generate support in between those areas. And then now you'll see that if I click and hold, I can kind of scroll around. You'll see that their support will be generated in all that green area, and that's it. Now if I hit done, that's it. It didn't generate support yet, but it's defining where support will be generated. So now if I go ahead and prepare to print, it should go a little bit quicker, and we should have a heck of a lot less waste of material, because it'll just generate support there. If you didn't turn on support material first, it'll just ask you, hey, look, I didn't turn my, and there's no support material turned on. Do you want to turn it on? And now you'll see we went from, I think it was like 300 grams down to 178. And we went from 100,000 millimeters down to about 60,000. And it went from 14 hours to 9. So a big, big difference. So don't waste support material and don't waste filament if you don't have to, because why? And you'll see inside of here now, there's all sorts of support material built just where I clicked. So this is a very, very useful tool. This is one thing that Simplify3D has that is absolutely just, you can put support anywhere, and if you want to go in later and remove support, just below the add support button is remove supports, and you can click each one of those individual support buttons and just take it out. I mean, it's really, really useful. So play with it and tweak with it. That's probably it's something that's going to save you a ton of time and a ton of money, really. So now that we have all those settings kind of set up, don't forget that you can always take this scroll bar here and scroll it down to see what your layers look like. I have it set to show movement speeds as well as retractions, and that's what these little blobs are everywhere. That's where the retractions are set up. And then the movement speed, obviously you can see that this is kind of the cyan color, which is somewhere between 30 and 40 millimeters a second. The infill is somewhere around 60 to 70 millimeters a second. If you click here, you can change active tool type. Well, we only have extruder 1 selected, so it doesn't matter. And then feature type. This is useful too because it shows you what's an outer perimeter, what's an inner perimeter, what's infill, skirt brim, all that stuff. So it depends on what you're looking for. I like movement speed just because it helps me visualize how fast this is going to print. But if you keep going down, here you'll see, here's that support I was talking about. So this is a support scaffolding, I guess you can say. Here, this is all the scaffolding. And then as you go further up, let me go to layer. Let's go. You can click here and just go layer by layer. These are the dense layers that are building up. So it looks like they're kind of thin, but that's the 75% thickness there. And it'll build up 2 layers of that. And then this is what's actually going to be used for the actual portions above. Okay, so now we've shown you part of slicing the model. We want to go ahead and split this into 2 parts because it was a little bit longer than we anticipated, but we want to make sure we cover all the settings. So if you want to see the other part of slicing the model, but also if you want to see us printing it on the gMax, click the next video and hope you enjoy.